A decision. Let's go with question, right? Healthy. So take an example. This is our column X and Y interpretable. Rubbing X, Y being of course our predicted column or sorry, target column. So the values here, let's take it as now regression. What happens is we split on every X and we try to calculate the purity or whatever, like purity, basically property. And the core intuition behind this is we need a loss which we want to minimize, right? So in this case, we can take it as take value which is minus sum of squared errors, right? What is this? Basically, our actual and the predicted square. So let's start our splitting and how we will do it. So we will take it as when x is greater than 6, right? What all values will be there? Let's plot this. Take here 7, 8, 10. 1, 2, 5. Right? For 6, it's 1. It's like linear. So these are the actual points. But what we are doing here is this is our first split, right? And in our first split, we will have x is greater than 6 and all the other values will be this, right? So what we do now is we calculate the mean of all these values and the mean of this, right? And we try to plot these values. So 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2, 14, 1, 2, 14 by 4. That is 7 by 2, this 5. Plot this, right? Like this. And now what we will do is from this we will calculate the error, sum of squared error, right? And this is the actual values, which is this one. These are the actual values. And this line represents our predicted values. So when we will calculate this, we will get a value of SSE, right? Which is the sum of squared errors. And let me put a summation here. So for each value, for the whole uh, splitting criteria, we will get SSE. And we will plot these SSE as well. So for example, we get somewhere around here. Then for the next split, we are going to take these two values and these three values. Then for the next split, we are going to take this pair and then we'll take like get the intuition, right? We will just shift one by one. So the beginning, we just put in the beginning we had x is greater, sorry, when x is less than 6, then we will have when x is less than 7. So we will have these 2 points in one criteria, right? And the mean of the other points, and we'll try to plot it and then again try to calculate the sum of squared errors. And similarly, we will have x is less than 8, x is less than 9, and x is less. So for all these values, we'll try to calculate the sum of squared errors. And for example, if it's like this, right? So we will take that split for which SSE is minimum, because this is the error and we want to minimize the error, and we want that split which minimizes the error. And yeah, that's pretty much it. We'll take that split. So that will be our first split. And then again, in our second split, we will do the same. And in the third split, and so on. How many, like if it's a full grown tree, it will go on until it reaches leaf nodes, whatever. So we can find this as an intuition, the decision tree regressor. Ah, yeah, ensemble methods, or rather ensemble technique. Ensemble. What is this? Ensemble is a um, group group of ML models, right? The group of ML models that we use together to make predictions. This is the basic idea. Make prediction. So, um, what do we mean by group of ML models? So, if you take an example of linear regression, try to predict the output, which is our the target variable. Sorry, no. Let me rephrase this. So, uh, for example, we have decision trees. 2, 4. Now, if I have data and if I try to send my data to this decision tree, it will give me an output, correct? Similarly, I will give this, this. All of these data, so give me output. Some output, let's say, these one are decision trees, right? So, for example, this gave me an output of 1, give me 0, this give me 1. Okay? What we are saying is, instead of a single decision tree and its output, we will take the output of all of these and we will look at all of these, right? We will look at all of these and then make a prediction, right? So in this case, this one is 1, this one is 0, this one is 1, and this. So अब इसमें से हम करेंगे क्या बेसिकली, जो जिसका मेजॉरिटी ज़्यादा है, विल लेबल इट एज, सॉरी, लेबल द पॉइंट एज 1, क्योंकि इसका मेजॉरिटी ज़्यादा है, राइट? एंड इफ इट वाज अ रिग्रेशन प्रॉब्लम वी वुड टेक अ मीन, ठीक है? और इसमें क्या आ रहा है, आउटपुट 1 आ रहा है बिकॉज ऑफ द मेजॉरिटी काउंट, एंड उसमें क्या होता, टू टेक द मीन, बेसिकली एग्रीगेट एज। एंसेम्बल मेथड्स जो होते हैं उनमें यही होता है, हम रादर देन वन डिपेंडिंग अपॉन वन machine learning model, we try to use one more than one machine learning model um, to make our prediction, and this way we are able to solve many problems. Now we will talk about them, but why is this beneficial? Because rather than depending upon one output, we are checking for the same data point with multiple models, and we are trying to form an intuition behind our output, right? Whether it is right or wrong in majority of the cases. And the regression one. We are just trying to calculate the mean, which is the average of all the points. So we are uh, closer to the actual value, right? Also, what you see here is the yeah. What you see here is decision trees, right? But it is not necessary to give all decision trees. You can give logistic regression model, give SVM, linear regression, you can give anything. But yeah, remember that it's not a hard and fast rule that every model has to be same. It can be different also, like one linear regression, one logistic regression, SVM, and so on. So you get the idea. Let's other things. Yeah, types of ensemble. So we have voting, we have bagging, we have stacking. All of these are ensemble technique. Yeah. So in the voting, it's the most basic one. It's basically you have various machine learning models and models, and on the basis of majority count and the average, you will get the output, which was the basic integral. And these models can be same or they can be different, right? Apart from this, we have bagging ensemble, right? And one more thing, the data, um, the differences, the major differences between all of these somewhere lies between the usage of data basically. The voting technique takes the data and feeds it to every ML model, ML, right? But the data is same. And if we talk about bagging, we have multiple models, right? And bagging, we try to take these models. Also, the data here that we are giving the ML models are dependent upon two things. First, it is um, row sampling, also have sampling. The row sampling says that I'm not going to give every row to these all models. I'm going to take random rows and I'm going to feed them. And it can be with replacement or without replacement. Thirdly, for feature sampling, we are not going to give all the features, all the columns, train the model. We can give any, like if there are five, we can give any three, give any two, we can give any one. But it is advised like not to give that many, that less of a number. Yeah, that's how bagging works. One of the best examples of bagging is random forest, which is widely used. Random forest, in this you can see like we have machine learning models. It only uses decision trees. It will only use decision trees to come to an output, and the data that it will get will be of row sampling and feature sampling. Then random forest will give. Why? Yeah, why it famous? Because it produces low bias covariance. And what is this? Low bias is basically the inability of a machine learning model to predict um, on the trained data set. So basically, when we don't have good accuracy on the trained data set, we say we have high bias, and when we say we have good accuracy on the trained data set, we have low bias. Similarly, variance is the difference in the accuracy when we are training the model on different subset of data. For example, if it is giving good on train but it is not giving on test, so we can say that it has high variance. So we want a model which is more generic, more generalized, which can give um, better results on different data, right? Different unseen data. So decision tree, when we employ this random forest, we are just giving multiple data or multiple kinds of data to the machine learning models, and they are not of the same type, right? There are different types. We are giving different rows. We are giving different columns were that are changing every time, that are random. So uh, when we do that, our model becomes familiar with more types of generic data, and due to that, our model doesn't tend to memorize the trained data too well, and just it just try to learn the parameters, right? Or I would it tries to not memorize but learn from the data. Yeah. So that's how it reduces the variance and it also reduces the bias. So that was it.